In this project, I will observe how launch angle affects the range of the projectile motion. My equipments are a launcher, a ball, one carbon paper, one meter, and I place the ball, the short range of a launcher like that. And again, I'll set the angle like this. And I will observe how angle affects of the range.
First, I set the launcher according to short range. Here, I set the launcher's gyro rate to 0 degrees to find the initial speed of the launcher. I calculated how many centimeters away the ball fell in how many seconds at 0 degrees using a stopwatch and slow motion video. The reason for this is to calculate the muzzle velocity of the launcher. Using the equations here and using the data I obtained, I calculated the muzzle velocity of the launcher. After a few test shots, I found the muzzle velocity of the launcher to be 3.95 with the data I obtained. I adjusted the launcher to 20, 70, 30, 60, and 45, and a few more angles. Again, using a stopwatch, slow motion, carbon paper, and a meter, I measured how much distance was traveled at each angle. Using my equation, I calculated the ranges at each angle. When we looked at the table I created based on my data, I calculated the theoretical values with the muzzle velocity that I found. And the error between the measured values and the theoretical values was minimal and the experience was successful. What I wanted to show was that the angles that complement each other at 90 degrees have the same range and the maximum range is measured at 45 degrees. As can be seen from the plot in the table that I created based on my experimental data, I showed that these theories are correct.